Hello everyone. So in this talk, we will be talking about protocols which are used to enable IoT systems. And these protocols are wired as well as wireless. So we will be discussing about various protocols in this particular session. So like first question which we want to ask is why protocols are important. See, to make any system work, we need to have a set of instructions which are also known as protocols. So to like enable IoT systems, we require certain set of protocols which needs to be followed. And let's see. So the Internet of Thing is something which is realized by the interconnectedness of the devices. So to enable this interconnectedness, we need various protocols. And in this session, we will see which all protocols are needed. So basically, there are two types of protocol. One is wired and another one are wireless. So first we will see wired protocols, and after that we'll see wireless protocol. And let me assure you that wireless protocols are much more interesting than wired ones, because wired ones is something very basic which we can see like everywhere around us. But wireless, like many new protocols are coming up every other week for the wireless Internet of Things. So that part would be more interesting. So let's start with wired IoT protocols. So these, like as the name says, wired protocols or wired Internet of Things protocols are like enabled through physical cables. Like we have real physical cable which goes from point A to point B to make sure that like our system works. So these wired protocols, like there are certain like advantages of these things, like they are more reliable and like offers stable connection. And these protocols are generally used to make connection between sensors and the microcontrollers or microcontrollers and the gateways. And sometimes if we are using like ethernet internet, then from gateways to the server as well. So let's see what are the advantages, what are the disadvantages, and various types of wired IoT protocols. So like as you can see in this image, there are many small like electronic components connected with each other. So how these components are talking to each other, that is defined by these wired IoT protocols. So one advantage of wired IoT protocols is they are much more reliable, because we know a clear path from where the signal has to transfer from point A to point B, and that the path is through the wires. So there are very less chance that some kind of interference will occur or some kind of intrusion will occur. And it offers better security because everything is like enclosed in a physical space, and like no one from outside can read those things. See, definitely it will like offer better speed, because because we know like at our home also like Wi-Fi is always slower than the physical LAN cable. So same things applies here, because if we have wires, we know like 100% the signal will go from point A to point B. And the range, like it offers good range, because through wires we can transfer the signals from kilometers to kilometers. But it also depends on the protocol, like how the signals are being transferred. So the range is something which may fluctuate for different protocols. So let's begin and start with the most basic IoT protocol, or let's say most basic like electronics protocol. This protocol is used in like almost like all of the electronic appliances, be it your smart TV, be it your speaker, be it your mobile phone, or be it your vehicle, or like anything. UART is the most basic protocol which is being used. It is a serial protocol, like the data goes after one after another. And this is basically used to like enable the communication between two devices over a shorter range of distances. and it is very simple to implement. There are various libraries and packages available for all the microcontrollers, and like this is the most basic protocol which if you are getting into IoT, you need to study about this thing and use it as well. And there are some disadvantages, like it can only be used for shorter distances, and like interference is also there. Second one is like I2C. So like advantage of I2C like over any other wired protocol is that we just require two wires to like enable this particular protocol, and we can connect multiple hardware on those two lines. So it works as a multi-master, multi-slaves. Like we just need to have two wires, and on those two wires we can connect hundreds or thousands of different devices or sensors or actuators, and like each sensor or actuator will have an particular address. So those two wide lines which we have, one is for the address and another is to transfer the data. And this protocol is also used in various sensors. If you start exploring any industry grade sensors, so most of the sensors work on like I2C bus, and it is efficient for shorter distances, but for longer distances there could be some synchronization issues, because see, like on two wires we are using so many hardware, so some issues will be there. But yeah, another thing to note down here is if we decrease the number of devices on I2C bus, we can increase the range or we can increase the speed. So that is one thing to note. Another important protocol for like enabling wired Internet of Things systems is SPI. SPI is, let's say, more advanced version of the protocols which we saw like earlier. So this also works on a master slave architecture, but there is always one master in this particular case, which is usually the microcontroller, and the slaves will be all the sensors and actuators. The advantage of using SPI is it works on like very high speed communication, and it requires more wires. It requires four wires to work for each slave. So like if there are multiple slaves and one master microcontroller, then the number of wires will increase for SPI. And SPI is also used like in many of the gateways. If you see anything with antennas, be it your Wi-Fi router or be it the cellular signals antennas, like those circuits will be having something or other which is working on these like SPI protocol, because it is very high speed. Now, like these three were the most basic electronics or like IoT protocols. Now we will move to something which is specific to like industrial IoT, or let's say for specifically for like IoT things. So one of the protocol is modbus. This is very much used in industry, manufacturing, like anything in your home which is manufactured in some or other kind of factory must have been gone through this modbus protocol, because the machinery which is controlling that manufacturing plant or the machines which are present in that manufacturing plant is certainly working on this modbus protocol. And like it is very simple to use, and like it is widely used in manufacturing and like other industrial grade IoT systems. This protocol, I think like every one of you have used, like if you are like a bit from the like older generation, because like earlier we don't used to have Wi-Fi everywhere, so we used to have that LAN cable which we have to drag and put it in the like Ethernet or RJ45 port in our laptop or computers. So this is also like very old protocol which is still being used in many IoT systems. This is used in industrial as well as like home or office networks. Advantages like high speed, it can support up to 1 Gbps of speed. Like I have 1 Gbps connection in my home, and through Wi-Fi I am only able to get 400 to 600 Mbps, but from Ethernet wire I get like exact 1 Gbps speed of internet. And uh, limitation is like you cannot drag it anywhere in the house. Like it can only be like enabled at a particular place. If you have a CPU in your room, then you can only use in that CPU. If you have laptop, then you have to physically put this wire in your laptop. You cannot use it like anywhere in the house like Wi-Fi. This is very interesting protocol, which is like OPC UA. This is like a unified architecture which was formed by the consortium of many companies who work on IoT. So this is a standard, like they made a particular standard from for like M2M communication or machine to machine communication. This protocol is also used in manufacturing and process controls, like in your electricity grids or your water system. Advantages, like there are many companies who make their own products. So all these companies thought like, let's make some unified architecture for our IoT products. So in this thing you can have a gateway from Samsung and a sensor from Siemens or a sensor from Honeywell, and they all will be working with each other. So this protocol provides interoperability, but at the same time this thing is a bit complex to implement. But for us, like we always have SDKs to just use these things easily. So this is the thing. Another protocol which is like almost used in all of the vehicles, be it your two-wheeler, four-wheeler, trucks, or anything else. So this is a standard protocol for your vehicles. You can also like access a part of this protocol if you have access to the OBD port in your vehicle. So what usually happens is like if you are driving a four-wheeler, there will be many things happening like engine RPM, coolant temperature, the speed of the vehicle, the like amount of the fuel present. So like all these things can be accessed through the CAN protocol. We just have to plug in a like OBD reader and all these information can be read. So this particular protocol is used in vehicles, or like vehicles, be it a two-vehicle, four-wheeler, or like trucks or buses or anything, but it is not used in like railways or like airplanes. For those things there are very specific protocols which we will not be discussing in this talk. So like the this scenario of wired protocol is very small. Like you only have certain set of protocols and they work like that. There is not much innovation happening in this particular field as compared to the wireless IoT protocols. So let's move on to like wireless IoT protocols and see how that scenario is coming up. So in wireless protocol, like we know, there is no physical connection. We can have two devices present anywhere. There is no physical connection between them and they are communicating with radio waves. So this is used in wearables, like your smartwatch is sending the data to the phone through Bluetooth, or smart cities where your traffic is controlled by some IoT protocols like the street lights. It is controlling the street lights or it is controlling the traffic signals. There are remote sensors which are reading the temperature, humidity, or like air quality values. Transportation, where you can track your vehicle, where is my vehicle present right now, or if you have booked an Uber, you can track where is your Uber. Like all this is happening through wireless protocols. So first of all, we'll see what is the advantage. I think everyone knows like it offers flexibility. It offers mobility, like you can move your things from one place or one room to another and it will still work. Scalability. So suppose there is a Wi-Fi in your house and you are using four laptops with that, and suppose your friend comes to your home, he or she also wants to use your Wi-Fi connection, they can easily connect to your network without any trouble. But same thing, if there was a LAN connection and you have to put an Ethernet cable, then there will be various issues. Like first of all, you have to put a cable in your router. After that, your friend will use that cable. And like again, range, like if we speak about 4G or 5G connections, so they work like all over your city, so it offers good range as well. Now, like first of all, we'll go through some protocols which are like, which we all have heard about. The first one is Bluetooth. So it is something which is for shorter range, because Bluetooth signals cannot move beyond say 20-25 meters. After that, they will start to decrease. And in Bluetooth, we also have various flavors of Bluetooth. Like we have BLE, which is Bluetooth low on energy. So BLE is used for systems like your smartwatch, because we need to conserve the battery life in the watch. We can trade off it with the range, but in smartwatch, either way, we don't need higher range, like maybe 2 or 3 meters. That's it. Uh, it is present everywhere, like any electronic device you buy, be it any smartphone or laptop, Bluetooth will always be present in that. And now, like, Bluetooth is mostly used with Bluetooth speakers, Bluetooth headsets, and all these things. Yeah. So Bluetooth is like the most basic wireless protocol. Second widely adopted wireless protocol is Wi-Fi. It is also used in many IoT systems. See, most of your smart home things will be using Wi-Fi, like smart lamp or smart speaker. Or if you take the case of Amazon Alexa, so like Alexa connects with the Wi-Fi to stream the songs or give any of the information to you. So it is used in local area networks, smart homes, offices, and the public spaces as well. High transfer data rate, I think with Wi-Fi 5 or 6, like we can get 1 Gbps of speed. But one thing to note is like it uses higher amount of electricity. So you won't find Wi-Fi protocol like in the appliances or IoT devices which run on battery. It is like always present is something which runs on the mains power supply. One important protocol for IoT is Zigbee. Zigbee is mostly used in home automation, and the advantages, it offers a decent amount of range with very less electricity. So if you have any of the IoT devices in your home which requires a special gateway, that IoT device is most probably using a Zigbee protocol. So Zigbee is also very similar to Wi-Fi, where you need to have a router or a gateway, and all the Zigbee clients will connect to that particular gateway. And like another advantage is it gives us the option to exploit the features of mesh networking. So mesh networking is something like if there are devices present, four IoT devices present in your home, they will relay their information from 1 to 2 to 3, and the third one will relay it to the gateway, and something like that. So all the IoT devices will be able to connect to each other and finally send that information to the gateway. Uh, Speaking about the range, so Zigbee gives a decent range of say 100 meters. So that is like decent for any of the smart home scenarios. Another protocol, like in the wireless protocol, the scenario is there is like always a fight between two protocols. So there is a fight between Zigbee and Z-Wave. So these two protocols like offer almost same advantages, and they have same disadvantages. But let's go through them. Like according to me, I think in the war between Zigbee and Z-Wave, has already won that war, and like Z-Wave is slowly going out of the market. So it also offers same flexibility that is of Zigbee, low powered wireless communication, and it is also used in smart home scenarios, mesh networking, and all these things. Now we will move to some interesting wireless protocols. Like the first one is my favorite, which is LoRaWAN. So when we see these particular protocols, they are called as long range wide area network, or like a wide area network protocols. So these are also wireless protocols, but the range is like 5 kilometers or 8 kilometers, something of that scale. So in LoRaWAN protocol, you can place a gateway inside your home. It's not very expensive. Like, you can place it in your home, and in your city, you will have your private network connection for say like 5 kilometers. So like any of the sensor you place in that 5 kilometer range will have the access to your private network. So, and these sensor, the most important like advantage of LoRaWAN is that it requires very low amount of electricity. So the sensors which are, let's say, battery operated can run for like 5, 6, or 8 years without any interference. So this particular protocol like offers long range with low power consumption, but at the same time there is the trade off with the speed. So you won't be getting any like gbps or mbps of speed. Like, rarely you will get 5 or 6 kbps of speed, but it is still decent if you have basic sensors for which you want to send the data. It is mostly used in smart cities and like also in smart agriculture. It is very much low powered. Like a battery operated device can also run for 5 years at least. And yeah, like transfer speeds are pretty low. uh, at the same time, like in this particular space, which is like LPWAN, low powered wide area network, there are many other protocols. Another one is nb-iot. So LoRaWAN is something which like operates on like ISM frequency band, which is industrial, scientific, or medicinal. But like nb-iot, for this you need to purchase the spectrum to run this protocol, and this protocol is usually like offered by the like ISPs or like sim providers in your area. So if there is Vodafone, like Vodafone will be providing 4G or 5G services, as well as they will be providing nb-iot. Similarly for AT&T or any other protocol. So like one advantage of nb-iot is, for these service provider or for these network provider, they don't have to install additional antennas to give access to this protocol. So if suppose AT&T already has thousands of antenna in a country, using those same antennas, using those same 4G 5G antennas, we can also give access to this nb-iot protocol. And it is also being used in smart cities, asset tracking, and for these also the sensors can be run on battery, and they will be providing battery life of say 5 6 years. I personally have used LoRaWAN as well as nb-iot, and these two protocols are very similar. The only advantage to go for LoRaWAN is like you can have your own private infrastructure, but with nb-iot you have to go with the network providers. Another important protocol in this particular space is like LPWAN space is sigfox. So like speaking of the advantages, same advantages. This gives low power, long range connectivity, and it is having same disadvantages, which are like slow data rate and all these things. So like it is almost similar to nb-iot and LoRaWAN, but this protocol is also like slowly getting outdated. So sigfox is moving also out. One important startup about which I want to talk about is uh, Lacuna. It is Project Lacuna. And what these guys are doing is they are placing LoRaWAN sensor in these satellites around the Earth orbit. And what they are claiming is like, if on planet Earth, from anywhere, if you have like access to the sky, you can see the sky from your line of sight, you can use LoRaWAN protocol because those guys already have the satellites in the space. So if you have any of the application where things are moving on a ship and you want to send some data to your server, then you can use LoRaWAN protocol to send that information from from that ship to the satellite using LoRaWAN protocol, and that satellite will relay the information to your servers. So like in the wireless protocol, many new things are happening. Now let's see like what is the comparison between wired and wireless. We cannot say like wireless is the winner or wired is the winner. Like almost in every case, these two things will work in conjunction of each another. So if you have a like IoT system, a complex IoT system, it is surely using wired as well as wireless protocols. The choice is up to you, like which wired or which wireless protocol you have to use, but these two protocols will always be used together. Most of the sensors, actuators or microcontrollers connection will be happening through wired protocols, and from microcontroller, when we are relaying the information to the gateway or from the gateway to the server, most of the time we prefer to use wireless protocols. So advantages of wired protocols is like they offer very good reliability and stable connection, and they are more secure because in wireless, like someone can eavesdrop on your signal and try to decrypt it, but in wired protocols there is no chance like anyone will be able to read your signal. And wireless protocol advantages, like you can place your sensor anywhere, you don't have to care about laying the wires or something like that. And like in wireless there are many protocol, you have to first understand your use case, after that choose between, like if your sensor or IoT device will be having access to like a mains electricity source, or you have to use a battery to operate your device, maybe it could be solar powered. And you also have to think about the speed at which you have to transfer the data. If you have some basic sensors which just has to send like a temperature or humidity values, then we can use like LPWAN protocols. But if you have some IoT device which is sending like say a video stream, then we require something high speed like Wi-Fi, or we can also use wired protocol like Ethernet for that. So when we talk about real world applications, like smart home is one of the scenarios where like IoT devices are growing at a very fast pace. So in smart home, if you see any of the device, it is using wired and wireless protocols. Let's say you have a smart LED present in your house. So that LED is actually an actuator which is controlled by a microcontroller. So that microcontroller to like LED IC signal will be something over wired protocol, but that like MCU will be connected to the server or to the internet via Wi-Fi or Zigbee or any other protocol. So like both wired and wireless protocol are being used. Similarly, with the case of like industrial automation, like suppose we have a factory where machines are working together to manufacture your products, something of the use. So those machines will be controlled by a protocol, let's say modbus. And in that smart factory, there are various sensors which are present, let's say temperature and humidity sensor, just to track the working conditions of that factory. For those sensors, we can have protocol like LoRaWAN to send the data to the server and all these things. So in short, like any IoT system will be using wired as well as wireless protocol. And if you are making a system, then first of all, you have to understand your use case, And after that, you have to see like which wired protocol I will be using or which wireless protocol I have to use. So this is the trade-off which you guys have to choose. And I think that's all for this talk. Thank you guys for listening to my talk. And like I am very much passionate about IoT, and if you guys are also passionate, then we can also connect on LinkedIn, or if you have any question or queries, you can like anytime ask me. I would be more than happy to answer it. So thank you guys. Have a nice day.